Today we're going to be looking at some more quadratic equations, and we are going to practice what we learned last class. It takes a couple of these to really feel comfortable. So we're going to do some specific examples and then some higher level of difficulty examples as well. So we're going to go ahead and start with our title today, which is More Factoring Quadratics. Okay, so our very first example that we're going to walk through is 2x squared minus 7x plus 3. So my recommendation is for you to refer back to your notes from yesterday as we're working through this. But our very first step is we go ahead and we make a diamond problem. And we pull out our a, b, and c from our equation. Our a is our coefficient of our x squared. Our b is our coefficient of our plane x, and our c is our constant. Okay, now we're ready to take that information and put it into our diamond problem. So our top, which is always multiplication anyway, is a times c. 2 times 3 is 6. And b bottom, b bottom, b bottom, b bottom. So we put our b term, negative 7, in the bottom. At this point, we're going to go ahead and solve our right and left. So our first, we always start with 1 times the number, and that adds to 7, and that's what we're looking for. So we have a 1 and a 6. Now, sometimes this is a little confusing to people, but we need them to add to be negative 7 and multiply to be positive 6. So when we multiply two negatives, they make a positive. When we add negative 1 plus negative 6, we do get negative 7. Okay? Now we are done with our diamond problem, and we're going to go ahead and fill out the inside of our generic rectangle. So this bottom corner is your ax squared from your original problem. So we're going to put a 2x squared there. The upper right corner is our constant from the original problem, which is 3. Now we're going to go ahead and take these two sides and we're going to put them in the two remaining boxes with an x. So we have a negative 6x, and here we have negative 1x, but negative 1x is actually just negative x. We don't need that 1 there. Now we're going to go ahead and factor that, solving the outside of our diamond problem. So this way I see a 2 and a negative 6, so I can pull a 2 out because 2 goes in evenly. There's an x in both, so we're going to make that an x. Now that I've taken one of them out, I can simply see what do I have to multiply to get that square. So 2x times x gives me 2x squared. X times negative 1 gives me negative x. And 2x times negative 3 gives me negative 6x. So I go ahead and take a look, and yes, indeed, that is negative 3 times negative 1 is positive 3. So I take those answers, 2x minus 1 and x minus 3. Okay, and that is product form. So this is product form. And product, of course, is the answer to a multiplication problem. My question was given to me in what we call standard form. And standard form is that ax squared plus bx plus c. Okay, and product form is my two products. Now, what we learned to do from here is we go ahead and we are going to find the roots, the zeros, the x-intercept. So 2x minus 1 is equal to 0, and x minus 3 is equal to 0. We're going to solve for each x. And that gives us 2x is equal to 1, x is equal to 1/2. And then our other one, we're going to add 3 from both sides, and x is equal to 3. Now that we have those two pieces of information, we can go ahead and find the vertex. Our vertex, we're going to add them together and divide by 2. I prefer to use them as decimals, and the reason why I prefer to use them as decimals is they're easier on my calculator. So I want to find the middle of these two. So 3.5 divided by 2 is 1.75. This is my x value, and then I'm going to plug it into the equation to solve for my y value of my vertex. So I have 2 times 1.75 minus 1, all times 1.75 minus 3. So times 2 minus 1, 2 times 1.75 minus 1, and that's 2.5 times 1.75 minus 3 times negative 1.25. We're going to multiply those two together, and I get negative 3.125, and that's going to be, and we're going to round to the nearest hundredths for these, so 1.75 negative 3.13, that is our vertex. So now that we have these two items, we can go ahead and graph. This, of course, we have lots of decimals going on here, but we have an x of 1/2 and an x of 3, and then we have 1.75 negative 3, and that is going to be our parabola. Now, as always, we can go ahead and check in Desmos by typing in 2x squared, our original standard form, minus 7x plus 3. And then we're going to write our product form, which is what we solved using our generic rectangle diamond problem, which was 2x minus 1 times x minus 3. And as you know, if I did it correctly, they'll be the same item. And then I'm going to click. I have a 0.5 and a 3.0 for my roots, and that's what I got when I solved using the zero product property. And then my vertex of my parabola, 1.75, negative 3.125. And then I also have my y-intercept, which is my 3. The place that we find our y-intercept for our equation is simply our constant, is our y-intercept. So that gives you one additional point. Okay, let's go ahead and try a second example. Our second example is 4x squared minus 24x minus 64. Now, what I want you guys to notice here is that they're all even numbers. In fact, they might all be divisible by 4. We're going to figure that out. But before we go ahead and do all the work of our diamond problem generic rectangle, you want to pull out any common factors first. And that's because we want to make it smaller, and then we'll see how that affects your final equation. But we can go ahead and take 4 out because 4 goes evenly into 24 and 64. So we're going to have that 4 on the outside. We're going to remember to put that in when we have our product form, but 4 is going to be x squared. Negative 24 divided by 4 is negative 6x, and negative 64 divided by 4 is negative 16. Okay, so now we're going to go ahead and solve using our diamond problem generic rectangle. So we go ahead and look at our A, our B, and our C. Our A is a 1, our B is a negative 6, and our C is negative 16. We're going to go ahead and multiply A times C for the top of our diamond problem, so negative 16. And our B bottom is going to go here. Now we're going to go ahead and solve our diamond problem. 16 times 1 adds to 15, subtracts to 15, adds to 17. Next we have 2 times 8, which adds to 10, subtracts to 6. Ding, 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 ding. So we have a 2 and an 8, and it's a negative 6, so that's going to be a negative 8. Now we're going to go ahead and transfer the problem into our rectangle. The bottom corner is always your x squared. The upper right is always your constant. And then we take our right and left, add an x, and make them our side by side. Okay, now we're going to go ahead and solve. The only way to get an x squared is x times x. X times negative 8 gives me negative 8x, and x times 2 gives me 2x. Negative 8 times 2 is negative 16. So we now have our product form, x minus 8 times x plus 2. So that again is our product form, our standard form. Now we can go ahead and find the roots by setting each of these equal to 0 using our 0 product property. We're going to add 8 to both sides on this one. We're going to subtract 2 on both sides for this one. So that gives me one root of 8 and our other root of negative 2. So we can go ahead and plot those. So there's our 8, there's our negative 2. We could also plot our y-intercept of negative 16 there if we want. Okay, now we can't forget that we do have a 4 on the outside here. So make sure, and when we put this on Desmos, we need to make sure we have that 4 on the outside. Otherwise, we're going to have different numbers. So now we're going to go ahead and find our vertex. So we're going to add these together and divide by 2. And so we have an x value of 3. And we're going to plug it back into our equation, not forgetting our 4 in order to find our y value. So we have 4 times the quantity. 3 minus 8 is negative 5. And 3 plus 2 is positive 5. So we have negative 25 times 4, which is negative 100. So that is our vertex. So that is going to be 3. And then all the way here, let's count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's going to be all the way down here. And then we do have our y-intercept as well. We can do our smooth curve. And we need our original equation to find our y-intercept. Don't make the mistake of using this one because that is times 4. So that is negative 64 there for our y-intercept. Now we can go ahead and check all of that work on Desmos. Our equation is 4x squared minus 24x minus 64. And as you can tell, I'm going to go ahead and add one more line here. When we took that 4 out and rewrote it, notice x squared minus 6x minus 16. I'd like for you to notice that when we have that, that is the same parabola. So once again, let me go ahead and change our settings here so we can see them a little bit better. We'll go from negative 5 to positive 5. So as you can see, and then we'll zoom out one, there we go. As you can see, these two are the same. So when I factor, it does not change my answer. And finally, my product form is 4 times the quantity x minus 8 times x plus 2. So once again, as we are looking here, that's a 4, we have 3 different equations all on top of each other because they're the same problem written in different forms. Now let's go ahead and check our roots. A root of negative 2, a root of 8, and our vertex of 3, negative 100, and our y-intercept of 0, negative 64. So all of that turned out perfectly. Okay, we're going to practice one last little one. We won't go all the way through. I just want to show you the setup to find the roots. So our last one is a weird example, x squared minus 25. And the reason I'm showing you this is because when we pull out our a, our b, and our c, our a is 1, our b is 0. We don't have an x. And then our c is negative 25. So as we go ahead and put this into our diamond problem, we have a times c up top, and our b bottom is 0. Now, whenever you have this, it's actually a pretty quick, good trick because we know the only way to add to 0 is by opposite. So that means it's going to be a perfect square up above, because 5 times negative 5 is negative 25, and then we add them to get 0. So a little trick there. We have our generic rectangle. Our x squared goes in the bottom. Our negative 25 goes up top. We have a 5x and a negative 5x for us to solve. And once again, the only way to get an x squared is x times x minus 5, and this is going to be a plus 5. So our answer is going to be x minus 5 times x plus 5, and we are going to have two roots, one at 5 and one at negative 5. And this means that our vertex is going to be right in between them. So our vertex is actually the y-intercept, 0, negative 25. So ladies and gentlemen, here's some more examples. We're going to continue working on this, and we're going to look at even more examples next class. So just take some practice, keep trying. I know there's a lot of steps. You might want to rewatch last time's video and rewatch this video as well to get the habit of how to solve these types of problems.